Okay, so yesterday we talked about multiplying radicals. And we talked about if it's underneath, then we can multiply and it stays underneath. Like, you're not even turned to page 12 right now.
Oh, shoot.
Okay.
Grabbing my thing, but I got
when we have, I don't want excuses. When we have division, the same thing happens. Okay. I'm going to zoom in here. The square root of a, can you stop talking, please? The square root of a over b is the same thing as the square root of a over the square root of b. So we can go back and forth between these two forms depending on what helps us the most. Okay. So we want to be as simple as possible. Okay. We don't want a radical in the denominator, and we'll kind of get to that more on page 13. Okay. But we're going to use this concept both forwards and backwards depending on what's going to help us the most. Okay. So like when I look at number 1, I think, oh, 49 and 100. Those are both perfect squares, right?
149 is, but 100 is not.
It is. Yep, it is. So we can break this up to the square root of 49 over the square root of 100 so that we can say, oh, hey, this is 7 over 10. Okay. Look at number 2. What do you notice about the fraction 8 over 32?
It's not square. It's not perfect.
It's not a perfect square. What else?
It goes in the 32.
We can simplify that fraction, can't we? And if we simplify that fraction, 8 over 32 can be reduced to 1 over 4. Okay. All right, well, now we can think of, the square root of 1 over the square root of 4. We could totally reduce that to be 1 over 2. Okay. Now, not always are we going to have nice, wonderful, perfect squares. Okay. Like, look at number 3. Okay, number 3, 3 over 16 is not a fraction I can simplify. 3 isn't a perfect square, but 16 is. That's nice. So I can think of, this is the square root of 3 over the square root of 16. I can break that up to where our answer is just going to be the square root of 3 over the integer 4. Okay. Write down what you think the answer to number 4 is.
I know for a fact that we have to put radicals on top of the fraction. So I'm just saying, if we do not write those, it will make it look like a fraction, and then we'll be easy like lose a point.
I don't know if I'm understanding your question.
So I'm saying, for instance, I'm trying to let's say if I did this from the answer, would I lose a point or like half a point because I didn't put the radical signs?
But the radical signs are gone because the square root of 40 is 7 and the square root of 100 is 10. So this is your answer. You will lose points if you put a radical there.
So
Okay.
same thing applies if it was supposed to be one as well.
Okay, so like here, we need square root of 3 over normal 4. Okay. Now, do you have square root of 7 over 7? Okay. Did some of you guys put 1 over 7 under your radical?
Yes.
Okay. So here's the problem with that. if you reduce this to 1 over 7, which is not unreasonable because I did encourage you to simplify fractions, this becomes the square root of 1 over the square root of 7. And you might have heard me say we are not allowed to have square roots in the denominator. Okay, so this technically is not a simplified answer. Okay, now when we get to page 13, I'll show you how to do that. And so you won't be in a pickle if that's the case. But what I was hoping you would see is that, oh, hey, square root of 49 is 7. So we have square root of 7 in the numerator, but 7 in the denominator. Okay, so hold tight and I'll show you what to do if you end up with something like this. Okay, but I'm not quite ready yet. Okay, all right, look at number 5. Okay, number 5, I see radicals, and neither of them are perfect squares. Okay, now we can do some simplifying, and maybe we'd have some things cancel, but you know what else we could do? We could totally do this. Okay, we go the other way. Why is that helpful?
You can simplify the fraction.
We can simplify the fraction. And this fraction would simplify to be, oh, I like that. Don't you? Because now we can go back again to 2 separate radicals for numerator and denominator. And since 9 is a perfect square, we can call that good. Okay, I'm going to have you try number 7. You try number 7. See what you can come up with. All right, what did you do first? Okay, changed it to be one big radical with 96 over 3 underneath. Ooh, can that be simplified? 96 over 3? What is it?
32.
Ooh, 32. 32 is definitely something we can simplify, right? 32 is 8 times 4, and 8 is 2 times 4. Ooh, so I have 4 squared. So 4 radical 2 is what that would simplify to be. Did you get that?
Yeah.
Pat yourself on the back. He's so proud.
Got that.
Okay, now, what if you're at number 9 and you're just like tunnel vision and you don't realize that you can put 5 over 45 under the radical? That's not the worst thing in the world, Because isn't 45, like maybe you're like, ooh, I know 45 is 9 times 5. And I'm really excited about that, right? So I have 3 radical 5 in my numerator. What's my denominator?
Would it be this radical?
Isn't it 3 radical 5? Oh! What's 3 divided by 3? What's radical 5 over radical 5? So we get 1. Okay? So what's kind of nice, when we have division in our radicals, there's not like a one exact way you have to use every single time. Okay? You have a little bit of flexibility. Now, what you don't have flexibility with is you cannot leave a radical in the denominator. So, let's go over here to page 13. Okay? We always need a rational denominator. A square root without a perfect square, like square root 7, square root 2, square root 10, those are irrational numbers. They do not belong in a denominator. We need an integer downstairs. Okay? So, if we have a radical in the denominator, then we need to multiply both the numerator and denominator by the radical from the denominator and then simplify.
Is this the one in your class?
They are next door in Miss Plinsky's. Okay, so do you see how in number 13 we have the square root of 7 in the denominator? That is no bueno. So we are going to multiply numerator and denominator by that radical that is in our denominator. Why do we do that? Let me show you. In my numerator, I have 4 square root 7. But what happens when I multiply the square root of 7 times the square root of 7? Square root of 49, right? Which is 7. And if you need me to show you this step, I can. But the whole point of multiplying by that radical in the denominator is so that when we multiply, we now get an integer. Okay? Now, why are we doing numerator and denominator?
Because it wouldn't be equal if you didn't.
It wouldn't be equal if we didn't. I'm essentially multiplying by 1. It just looks like radical 7 over radical 7. But multiplying by 1 does not change the numeric value. Okay? All right, let's look at number 14. It is not okay to have square root of 2 in the denominator. And I can't even be creative and make this the square root of 5 over 2 because that's not something we can simplify either. So I'm going to multiply numerator and denominator by whatever radical is in my denominator. What do I have in the numerator?
10.
Radical 10. But in my denominator, I have the square root of 4, which is just 2. I want you to try number 17. We're going to come back to 15, but I want you to try 17. Good luck.
Oh, thanks.
Yep. Okay, did you multiply numerator and denominator by radical 2? So what do we have in our numerator?
4 radical 6.
And what about our denominator?
Just radical 4. Just 2.
Okay, radical 4, which is 2. Okay, now, here's where we need to be careful. Okay, will you make sure you have this? 4 radical 6 over 2. Now, anything outside the radical, we can simplify together. So do you see how we essentially have 4 divided by 2 outside of the radical?
Yeah.
Which means we can take 4 divided by 2 and keep it outside of the radical. So your most simplified answer, the one that I would need, is 2 radical 6. Good job. Okay. Okay, let's look at number 15 because 15 looks kind of weird. Emily, what do you suppose we should do with number 15?
9 over radical 9 over radical 2.
Okay, I like where you're, so let's break it up into like 2 separate radicals. Okay, but you were right the first time. 9 over radical 2 is what we've got going on. Okay, but it is not okay to leave radical 2 in our denominator. Okay, so we'll multiply numerator and denominator by radical 2 so that we get 9 radical 2 over radical 4, which I'm just going to write as 2. You can definitely make these problems more complicated than they need to be. Okay, so I want to go through kind of some, I don't know, like I want you to look at number 16. Yes, we can break this up into square root of 6 over square root of 18 and then multiply by square root of 18. We're going to have a little bit of a mess. What do you suppose would be a good idea to do before I do any of that? Okay, 6 over 18 can be simplified to be 1 over 3, can't it? Okay, so at this point, I have the square root of 1 over the square root of 3. Okay, but can we leave it like that? No, we can't. Okay, so we need to multiply numerator and denominator by square root of 3. So we have radical 3 over 3. Okay, I want to look at 18 because even though it looks a little bit straightforward, I get some questions about what the heck to do with that 10. Okay, so I have radical 4. Oh, I have radical 4. Oh, well, that's crazy. So I have 2 over 10 radical 3. Okay, I don't want radical 3 in the denominator. Okay. Is 10 okay? 10's fine. It's an integer. Okay. I just can't have radical 3. So the only thing we need to multiply by is the radical 3. Just the square root. The 10 is just fine. Okay. So we get 2 root 3 in the numerator. What does my denominator become? 30? So it would be 10 radical 9, correct? What's radical 9? 3. And what's 10 times 3? So you betcha this is 30. Okay. Vivi asked a question. Can this be simplified? Yes. We can simplify this 2 over 30. 2 over 30 is 1 over 15. I'm cool if you write the 1. It's not necessary to write the 1. Okay. Now, I know that 3 and 15 look like, ooh, hey, that's a fraction that can be simplified. But remember, 3 is under the radical, 15 is not. So they have nothing in common with each other. I can't simplify when one number is underneath and one is not. Okay? So here's what I want. I want you to come up with an answer for number 20 and number 21. I'll give you about 2 to 3 minutes to come up with an answer for those. We'll check them, and then we can work independently, okay?
So I don't know how to do this stuff, but I just think something that's gonna get me a little mixed up is just when I have to put the radical sign or not. Like, because I know when I don't have to, it's a perfect square. I know that, but it's just like when we put it like under like a radical bar like that, it can be a little confusing to figure out what has the radical and what does not.
Okay, so how about you try 20 and 21, and we'll see maybe where we're getting messed up, okay? So you're trying 20 and 21. Yes, you do need to because the 2 over 30.
I knew what I did. I'll tell you maybe.
Ah, pretty nice that we did number 18, huh? Is number 20's answer a little bit similar to number 18's? Did you get radical 6 over 15? because when we multiply by radical 6, we get 2 radical 6 over 30, which simplifies to this. Okay. In 21, did you multiply by root 2? So you have 4 squared at 10 over 12? So you simplify it to be 3 in the denominator? Good. Okay. So here's what I need from you.